teacher.
Yes, good morning, Maklay. Good morning. How are you all?
Fine, teacher.
Fine. Yes, all are safe at home and doing well, I hope, isn't it?
Yes,
Yes.
teacher.
Okay.
Sure.
Yeah. And did you do the assignment which was given yes previous
Yes,
class?
teacher.
Yes,
Yes.
teacher.
Okay. Very good. Very good. Very good.
Yes, teacher.
Yes. Now you may be wondering why I am standing here, isn't it?
Yes, teacher.
Yes.
Yes,
Yes,
teacher.
teacher.
Yes, teacher.
Yes, okay.
Yes.
So, as always, you are very lucky people. Okay, so to have a special class for you. This is, we are going to experience a new innovative way of learning. Okay, and so many modern technologies you have already come across, that is, there is artificial intelligence is there, virtual learning is there, then there is augmented reality. Okay, so today, as you people are very lucky, we are going to have a very special class with a sort of experiential learning with the augmented reality. So that is the first class which you are going to get with augmented reality, which is the modern technology, innovative technology at present which you are using it. Okay, so if you till now we were using the PowerPoint presentations, slides were being used, but in this reality there is a slight difference. So if you want to see me on the whole screen, then you should, if you are using a mobile phone, then you have to long press the image of my screen, then you have to pin it. So those who are using the mobile phone, do a long press, then you have to pin me, then again you have to do long press, and then you have to fit to frame. Okay, so is it clear, Makle? If you want to see on the whole screen, then you have to, if you are using mobile phone, do a long press, then you have to pin me, then again do a long press, then you have to fit to frame. Those who are using laptop or desktops, they can use the right click button, and then you have to pin, again right click, you have to fit to frame. Okay, is it done? All are comfortable?
Yes, teacher.
Yes. So you can see the screen there?
Yes, ma'am.
Yes, okay. So, uh,
Yes, ma'am.
all the best. We are going for a journey, and you all will be with me, I hope, isn't it? You'll enjoy today's class. And we are the basic chapter which we are going to already we have been learning is about acids, bases, and salts. So that was the top chapter which we were been discussing, isn't it? Yes. And already in your previous classes, you have learnt about some of the properties of these acids, isn't it? So, Sravani, can you tell me? Sravani? Hello, Sravani, can you unmute yourself?
Yes, teacher.
Mane, what properties you know about acids?
Teacher, acids are sour in taste.
Very good.
Next, they are soluble in water.
Yes.
Next, they conduct electricity.
Very good.
Next,
Okay, okay. You said three properties. Very good, Molly. Excellent. Okay. So
thank
that
you,
is
teacher.
acids. They are corrosive in nature, isn't it? In your previous classes, small classes, you have learned acids are corrosive in nature. If it falls on your skin, it will get you burnt, isn't it? So they are corrosive in nature. Then they are soluble in water, isn't it? If you mix with the water, it will dissolve in it. Then they have got a sour taste, isn't it? That is the basic characteristic we can see of acids, that they will be having a sour taste, isn't it? Then they conduct electricity, isn't it? These are some of the common properties which we find in acids. Now let me talk about base. So Nandan is there?
Yes, teacher.
Yes, Mone, thank you for responding. Can you tell me some of the common properties of base?
They conduct electricity.
Very good.
They are soapy in touch.
Soapy to touch,
They are bitter in taste.
bitter in taste.
And
Are they
they
soluble in water?
Some of them are soluble
Very
in
good,
water.
very good. Yes, very good, very good. Excellent, Manu. Okay, so these are some of the properties of bases. That is, bases, they are bitter in taste, isn't it? Then they are, some of the bases are soluble in water, and the bases which are soluble in water, what do we call them? Alkalis, very good. Alkalis, isn't it? The bases which are soluble in water, we call them as alkalis, which do not dissolve, we can call them as non-alkalis, isn't it? Yes, that is how the alkali metals and alkaline earth metals and all comes. Okay. Then bases, they conduct electricity, isn't it? They are soapy to touch. So these are some of the properties of bases. Now, we will be discussing one more specific characteristic about an acid. That is, acids when mixed with water, we said already, it dissolves, isn't it? So when it dissolves, it furnishes or it produces which ions? H plus ions. That is, acids when mixed with water, you can see H plus ions will be formed. When dissolved in water, it produces H plus ions. H plus aqueous ions are also called hydronium ions, isn't it? They are also called hydronium ions. So we can see an example here, that is hydrochloric acid. It is an acid when dissolved in water, that is for representing water only, we are saying aqueous, AQ, isn't it? When dissolved in water, it will produce H plus ions and Cl minus ions, isn't it? It will produce H plus ions and Cl minus ions. Okay, so that is about the acids property. That is, acids when dissolved in water, it will produce H plus ions and Cl minus ions. Now we can see through an image, that is through an image. Now this acid, that is hydrochloric acid, when mixed with water, what will happen? HCl is what type of compound, do you know? No, whether two types of compounds you have learnt in your previous classes. What type of?
Ionic
Ionic
compound.
and
Yes,
covalent.
ionic and covalent.
Ionic
Yes.
and
So
covalent.
HCl, as
Ionic.
HCl, does it show any acidic nature? Is it acid
No.
with HCl alone?
No.
No, it doesn't behave as acid,
No.
isn't it? So then what type of compound is it?
Covalent compound.
Covalent compound. Yes,
Covalent.
HCl is
Covalent.
a covalent compound. But when mixed with water, when HCl is mixed with water, what will happen to HCl? It will break down into its corresponding ions. That is, break down into H plus and Cl minus ion, isn't it? So that is how ions are formed, isn't it? And this H plus ions concentration, if it is more, that is, if an acid breaks down completely, the breaking down of an acid into its corresponding ions, what is that process called? Do you know? Yes,
Ionization.
ionization. Very good.
Ionization.
Ionization. You can
Ionization.
also call it dissociation. Okay. So this H plus, if it breaks down completely, then we call them as strong acids, isn't it? That acids which dissociates completely, we call them as strong acids, and the acids which dissociates partially, we call them as weak acids. So acids we can classify as two: strong acids and weak acids, depending on their ability of ionization. Okay, so that is about acids. Now next, what do bases do when you dissolve in water? When bases are dissolved in water, they also break down into their corresponding ions, isn't it? And there, which ions are formed? OH minus ions. Yes.
Hydroxide.
Hydroxide ions are formed, isn't it? OH,
Hydroxide.
yes, OH minus ions are formed, isn't it? So that example we can take one: sodium hydroxide here. Sodium hydroxide, when we mix with water, what will happen? It will break down into its corresponding ions, that is Na plus ions and OH minus ions, isn't it? So that there also dissociation, ionization takes place. Bases also, when dissolved in water, ionization takes place, isn't it? Now, this also we can see through an image, isn't it? You can see an image, that is, bases when mixed with water, what will happen? They will break down into their corresponding ions. Like hydroxide ion will be formed, and B is the metal there, so B plus ions will also be formed. Okay. Now, if this dissociation takes place completely, then what type of base will it be?
Strong base.
Strong bases, yes.
Strong.
If it
Strong
dissociates
Strong base.
completely, they will be strong base. If it dissociates partially, then they will be of weak bases.
Weak
Okay,
base.
so that is about, yeah, very good, Makle. So that is about acids and base, isn't it? Now, if you want to know what substances will be used for it, for testing whether a substance is acidic or basic. Yeah, very good. Indicators, isn't it? So indicators are substances which are used to check the nature of an acid, whether it is acidic or basic, isn't it? Now these indicators, there are two types of indicators. One we call them as natural indicators. The other type of indicators we call them as artificial indicators. So two kinds of indicators are there: natural indicators and artificial indicators. Okay, now what are natural indicators? Natural indicators, that we
That
get
are
from
obtained from
nature.
nature.
That is
Obtained from nature.
very good. That is that we get from nature. The indicators which we obtain from nature, they are called natural indicators. Examples for that you can see hibiscus flower is there. Then there's beetroot is there. Then litmus. Litmus is also a natural indicator. Then you have got red cabbage. Then there is turmeric is there. So these all are examples for natural indicator, isn't it? Now this turmeric and all, if you put on, if by chance if it falls on your dress, then if you apply soap, what color change do you observe? Reddish brown in color, isn't
Reddish
it?
brown.
So soap actually contains what? Base, yes. So in basic medium, what color change this turmeric will show?
Reddish brown.
Reddish brown in color. Yes,
Reddish
yes.
brown.
So these are all examples for natural indicators. That is, they indicate with a color change in different medium. In acidic medium, it will show one color. In basic medium, it will show another color. Okay. Now, next type of indicator, what is it? Artificial indicators. Yes, artificial indicators. So artificial indicators example also you can see methyl orange is there, then phenolphthalein is there, isn't it? Now methyl orange, what is the color of methyl orange in acidic medium? It is red in color. Yes, methyl orange is red in color in acidic medium, and in basic medium it will be yellow in color. Yellow in color. In basic medium it will be yellow in color. Okay. Now, so that is the color change. The artificial indicator methyl orange shows in acidic or basic medium. Then what about phenolphthalein? What is the color of phenolphthalein? Yes, it is colorless. Yes, phenolphthalein is colorless, but when it is put in an acidic solution, what will happen? No color change. You will see no color change. In acidic medium, you can see no color change, but in basic medium, what is the color change? Pink. Very good. Pink. It turns to pink in color. Okay, so that is the color change which is shown in the case of phenolphthalein. That is the indicator phenolphthalein. Okay. Then next, one more type of indicator you have known. What is it?
Olfactory.
This one, see on the screen, we have got a
Olfactory
special type of indicator called pH indicator. What is it called? pH indicator. So all the other and in that we use universal indicator, isn't it? And its value ranges from 0 to 14. In the pH indicator, the value ranges from 0 to 14. Okay. Now, if the value is 7 and the color there is green, that time it is neutral in nature, isn't it? And if the color ranges from less than 7, when the pH is less than 7, then it will be what in nature? Acidic in nature. Yes. And if it is more than 7, it will be basic in nature. Okay. Yes. So if the value of this pH is 0, 1, 2, then it is of what type of acid? Strongly acidic. Yes, it will be strongly acidic. That is, the pH value from 1, 0 and 2 will be strongly acidic. Now, if the value is 7, then it is neutral in nature. And what is the color there? Color green. Yes, neutral has got a green color. Now, if the pH color range from 12, 13, 14, then what is it? Strongly alkaline. Yes, it will be strongly alkaline. So that is about pH indicator, isn't it? In pH indicator, we have got a scale from 0 to 14. And if that is the color range you can see, does it look similar to something?
Rainbow.
Yeah, very good. Rainbow, isn't it? Vibgyor. You can see that is violet, indigo, blue, green, yellow, orange, red, isn't it? That is the Vibgyor color range you can see in the scale of pH, isn't it? That is the pH indicator, and if the value is 7, it is called neutral. If the value of pH is less than 7, it is called acidic. If its value is more than 7, it is called alkaline. So it actually measures the strength of acid, how strong an acid is. Yes, how strong a base or how weak a base is. For that only we use this pH indicator. And who has discovered it? Sorensen. Yes, Sorensen has discovered the pH scale. Okay, so that is the pH indicator. Now what else is left? One more indicator is left, that is called the olfactory indicator. Yes, olfactory, as the term itself shows, olfaction means olfactory senses, like, isn't it, smell. So you can distinguish it with the change in smell, isn't it? So example for these olfactory indicators shows with the smell change, isn't it? In acidic medium, it will retain its smell. In basic medium, it will lose its smell. So example for olfactory indicators, we have got onion is there, vanilla is there, clove, all these extracts can be used as the olfactory indicator. So in acidic medium, it will retain its smell, and in basic medium it will lose its smell. That is why if you keep onion inside one cloth piece, then and you go and wash with soap, will the smell of onion be there?
No.
No, that means in soap is a base. So basic medium, when you apply, the smell of onion is lost, isn't it? So that is how it will indicate. That is, olfactory indicators will indicate with a smell, change in smell when it is in acidic or basic medium. So these are the different types of indicators which we had discussed, isn't it? Now, based on this chapter, there is one experiment, isn't it? Experiment, that is to study the properties of acids and bases by their reaction with litmus solution, zinc, and sodium carbonate. So that is an experiment, practical experimental part, which you'll be discussing based on this chapter. Okay. So let's move with the first one. How do these acids and bases react with litmus solution? How is the color change it shows? Now, do you know litmus? From where do we obtain litmus? Litmus, yes, it is obtained from lichens, isn't it? That is lichens. It is actually a symbiotic relationship between an algae and fungi, isn't it? Algae and fungi, that is, one will provide the nutrition, the other will give the shelter, isn't it? So that way a symbiotic relationship between the organisms happen, and that we call lichens, isn't it? And from the extract of these lichens only we prepare the litmus solution. So that is why it is a natural indicator. Okay. Now this litmus solution, how is its action with the acids and base? So two types of strips are there, that is blue litmus paper is there and red litmus paper is there. Then we have solution of ammonium hydroxide here. We can also take sodium hydroxide, that is a base. Then we have a hydrochloric acid, isn't it? That is an acid. Now let's see how the color change is observed in this litmus paper. So first we are going to take the blue litmus paper. Okay, so blue litmus paper is taken, then it is placed on the petri dish, isn't it? And a dish or a white tile you can place. Then you, with the help of dropper, you take a few drops of acid, then you pour on the litmus paper, blue litmus paper. What color change you observe there?
Red.
Yeah, it turns to red, isn't it? So acids, acids turn blue litmus to red, isn't it? Now if you take a red litmus paper and you put a acid there, will you see a color change? You just see. Yes, here we are going to put acid on the red litmus paper, so no color change is observed. So if you want to check for acid, which litmus do we use? Blue litmus, isn't it? Now check for the bases, isn't it? Now bases you put on red litmus paper, blue litmus paper you are going to put. Yes, So what is the color change? On red litmus paper when you put, red litmus will turn to blue, isn't it? Red litmus will turn to blue. Now if you put it on the other litmus paper, if the base is put on blue litmus paper itself, will you see any color change? No color change will be observed, isn't it? So for testing bases, which litmus is used? Red litmus is, yes, red litmus is used for testing bases, and blue litmus is used for testing acids. Okay, so that is how the color changed. So acids they turn blue litmus to red, and bases will turn red litmus into blue. Now what is the next activity there? Yes, next activity is reaction of acids and bases with metals. How do these acids and bases react with metals? Okay, now you can see we have taken hydrochloric acid in the conical flask. We have taken hydrochloric acid. To that, what is added? Zinc metal. Zinc metal is added. Zinc metal is added. So you can see zinc granules are added. If you watch closely, is there any bubbles formed there? Yes, bubbles. So immediately bubbles. See, you can, if you break, that is a hydrogen gas is released. Whenever an acid is mixed with a metal, hydrogen gas is released. If you bring a lighted matchstick near the gas, you will hear a pop sound. So that is the standard test to check for the liberation of hydrogen gas. So you can see the equation here, isn't it? Yes, hydrochloric acid reacts with zinc, isn't it? So zinc is reacted. So which salt is formed? Zinc chloride is formed. Yes, and hydrogen gas is released, isn't it? So now if we can say a general reaction, isn't it? General reaction can also be said what? Acids whenever mixed with a metal, isn't it? That metal must be a stronger metal, reactive metal than hydrogen. Then only this reaction will take place. Okay. Then what will be the product formed? Salt and hydrogen gas. So whenever a metal is put in an acid, which gas is released? Hydrogen gas is released. How you test for hydrogen? Just bring a lighted matchstick near the gas. It will produce a pop sound. Okay. Now do bases react with metals? Usually bases usually do not react with metals, but strong bases like sodium hydroxide, they will react with metals like aluminum or zinc, isn't it? For this activity, you have to take a conical flask, you have to take, then in the conical flask, you have to add the sodium hydroxide pellets. Okay, now have you seen sodium hydroxide pellets? So yes, so now we are going using the spatula, we are going to take the sodium hydroxide pellets. See the sodium hydroxide pellets, now you can see clearly. Then that you have to put in the conical flask. Okay, now we need to dissolve it. The sodium hydroxide as such, it is not going to react, so we have to dissolve it using distilled water. Okay, so we will add distilled water, then we will try to dissolve it, isn't it? So when we shake it, it will slowly dissolve. This is what type of reaction, you know? This process, what will you call?
Ionization.
Yes, ionization. Yes, it is called ionization. Now, ionization is what type of reaction?
Exothermic.
Yeah, very good, very good. Exothermic. That is dilution of acid and bases, isn't it? That is exothermic, isn't it? So if you touch the outside of the container, it will be hot, isn't it? Now the sodium hydroxide solution is prepared. To that we are going to add aluminium foil. Okay, we will be adding aluminium foil, or you can also add zinc. Okay, so aluminium foil is put in the conical flask. So few more pieces of aluminium foil we will be putting. Then this reaction is slow one, so it will take little bit of time. So we will close the lid of the conical flask to see whether any reaction, because otherwise if whether any gas is being produced, we want to check, no? So we will close it and see whether any gas is being produced. So is there any reaction taking place? If you observe closely, yes, you can see some, yes, some bubbles of gases, isn't it? Hydrogen gas is, yes, hydrogen gas is evolved. Now what is the test for hydrogen? just bring a lighted matchstick
Lighted
near the gas,
matchstick.
you will hear a pop sound, isn't it? Now if you apply a soap solution there, the inside the bubbles, what is trapped? Hydrogen gas is trapped, and you bring a lighted matchstick, what will happen? That will burst with a pop sound. So bases, that is strong bases, also react with metals, isn't it? And the reaction here was what? Aluminium metal reacting with sodium hydroxide and water, that is solution form is there. So what is formed? Which salt is formed? Sodium aluminate, isn't it? Sodium aluminate, that is
Sodium aluminate.
NaAlO2. Plus what is the other product there? Hydrogen gas is produced. This reaction
Hydrogen
also
gas.
can happen with zinc, isn't it? If it is sodium hydroxide is reacting with zinc, then what product will be formed? Sodium zincate. Yes, sodium zincate, that is
Sodium zincate plus
ZnO2. Along with that, hydrogen gas will be released. So that is the reaction of acids and bases with metals. Now what do we have to do the next one? Yes, reaction of acids and bases with
sodium carbonate.
sodium carbonate. Now, yes, sodium carbonate, what is the formula for sodium carbonate and all you know, isn't it? For this experiment, we need to have this iron stand should be there, test tube should be there, delivery tube is there, then thistle funnel through which we will be putting the sodium carbonate, all these materials are needed. Now, we will take 5 milligrams of sodium carbonate will be taken and put inside the test tube. Okay, then we'll make a solution of it. We have to add water in order to make solution, and in the other test tube we are going to check for the gas, which gas will be released, and we are filling there with lime water. Okay, so we are filling there with lime water. What is lime water?
Calcium hydroxide.
Calcium hydroxide. Yes, lime water is
Hydroxide.
calcium hydroxide. Now, with the help of the delivery tube, we are connecting these two test tubes, isn't it? That is, and that is one test tube is there. With the other test tube, it is connected. Okay. So, through the thistle funnel, what will be pouring? Inside the test tube, we have taken sodium carbonate. Now, what do we pour through the thistle funnel?
Acid.
Yes, very good. Acid. We have to pour the acid. So here we are going to pour hydrochloric acid. So through the thistle funnel, we will be putting hydrochloric acid. Okay. So when we put hydrochloric acid, this hydrochloric acid will react with the metal carbonate, sodium carbonate present inside the test tube. So immediately what will happen? A reaction will take place. You can see bubbles of gas is being evolved, isn't it? Those bubbles of gas, it is passing through the lime water, isn't it? So when it is passed, what is happening to the lime water? For some time when you pass, yes, it will turn to, turns to milky. Yes, yes, it will turn to milky. Okay. Now the reaction for this experiment, what is it? That is, we have carbon dioxide gas is evolved, isn't it? That is, carbon dioxide gas makes the lime water milky, isn't it? So here we have taken hydrochloric acid. Hydrochloric acid, to that we are adding sodium carbonate, isn't it? Sodium carbonate. Do you know what is the common name of sodium carbonate? Soda ash, very good. Soda, yes, not caustic soda, soda ash. Yes, so sodium carbonate, it is commonly called soda ash. When it is having the water molecules, that time we call them as washing soda. Yes, washing soda. Yes, washing soda. So these two things mixed, what will happen? Sodium chloride, the salt sodium chloride is formed, along with that water is formed, and which gas is released? Carbon dioxide gas is released, isn't it? So whenever an acid is mixed with a metal carbonate, carbon dioxide gas will be released. How you test for carbon dioxide? You have to pass the gas through lime water, isn't it? Calcium hydroxide. When you pass through lime water, what will happen? It turns milky. Why it turns milky? Why it turns milky?
Because of the presence
Due
of
to the
calcium
formation of,
carbonate.
yes, calcium carbonate, which is an insoluble salt. Calcium carbonate is an insoluble salt, so it turns milky, isn't it? Now, if the carbon dioxide gas is passed for a longer duration, if you pass it for a longer duration or more time, what will happen? the milkiness will disappear. Why milkiness disappears? Because of the formation of the soluble salt calcium bicarbonate. This soluble salt called calcium bicarbonate is formed. That is why the milkiness will disappear. Okay, so that is the reaction of acids with sodium carbonate. Okay, now next we have to do the reaction of bases. Do bases react with sodium carbonate? Bases do not react with sodium. What is the reason why bases do not react with sodium carbonate?
Because it itself is
Yeah,
base.
very good, very good. Both are bases. What is the nature of sodium carbonate? Basic in nature, isn't it? Yes, sodium carbonates, basic in nature. So both bases, if you react, nothing is going to happen. It will become more basic in nature, isn't it? So no reaction will happen. Bases do not react with sodium carbonate. Okay. Now next, these three chemical properties we discussed. Now next, if we mix acid and base, what will happen? Salt will be formed. Now here we have taken hydrochloric acid, then here we have taken sodium hydroxide solution. So universal indicator when added in sodium hydrochloric acid, which color? Pink in color. Then universal indicator when added to sodium hydroxide solution, you can see a different color, isn't it? So that is in the pH indicator we said what all color changes, different colors it show, isn't it? So in the universal indicator when added in basic solution, it will show a blue color, isn't it? So one is pink color and one is the blue color. So mix it well. So that is the color range it pH shows in different mediums. Now, you want to see a magic? You want to see a magic? Yes, then see, if we pour this acid in basic, what color change? What color? Yes, what color? Yeah, green color, isn't it? Green color represents what? Neutral. Yes. So when we mix these two substances, a green colored substance is formed, isn't it? That means the solution is neutral in nature, isn't it? So hydrochloric acids pH is less than 7, sodium hydroxide pH is more than 7. So this acidic solution and basic solution, that is when added with universal indicator, acid will show the pink color, base will show the bluish color, and these two colors when we mix, that is these two solutions when we mix, we will get salt and water. Along with that, what else is produced? Lot of heat will be produced. So this is also a exothermic reaction. This is a exothermic reaction, and this type of reaction when we mix acid with a base, what do we call that type of reaction? Neutralization reaction. We call it as, yes, neutralization reaction. So since the salt form is neutral, that is why the solution is turning green in color. Now are the all salts neutral in nature? No. So if we want to get salt, we have to add acid and base, isn't it? So acid and base when mixed, we will get salt and water. Now this nature of the salt depends on what? Depends of the parents, isn't it? Acid and base are the parents of this salt, isn't it? Acid and base are the parents of salt. So the nature of the salt depends on the acid and base from which it is formed. So from this salt, we are going to prepare a chemical substance. So we will see what chemical substance can be prepared using this one salt, that is from the calcium family of salt. We are going to prepare bleaching powder. Have you heard of this term, bleaching powder? Yes, at your home also. Yes, at your home also, for many purposes, for cleaning and all, you will be using bleaching powder. The term, before going further, you must know what is the term bleaching. Bleaching, what the term bleaching means? Yes, it means to decolorize. That is, if you want to bleach something, means if you want to reduce its color, if you want to dim its color, if you want to make it little lighter, that is the That is the purpose it does. That is how it got its name, isn't it? Bleaching powder. So what is the chemical name of bleaching powder? It is calcium oxychloride.
Calcium
Calcium
oxychloride.
oxychloride, or you can also call it calcium hypochlorite. Okay, calcium oxychloride or calcium hypochlorite. So that is the chemical name of bleaching powder, calcium oxychloride or calcium hypochlorite. What is the chemical formula of bleaching powder? The chemical formula is CaOCl2. What is the chemical formula? CaOCl2. Okay, so yes, CaOCl2 is the chemical formula of bleaching powder. Now, do you know how is it prepared? Do you know the preparation? Do you want to see the preparation? Yes, it is prepared using Bachmann's plant. What is it? Bachmann's plant. Okay, so this is a plant, that is a whole plant. It is made of the iron cast iron. It is made of this cast iron. Then at the bottom you have got two inlet pipes. One inlet pipe is for hot air, the other inlet pipe is for pumping the chlorine gas. Okay. Then at the left side top you can see a outlet is there, isn't it? Outlet for waste gas. Whatever waste gas is produced, that will move out through this, and there is a hopper at the top, isn't it? So this is how the structure. Now see how we will move inside to this plant. What is happening inside to this plant, isn't it? And the raw material used for this preparation of bleaching powder is calcium hydroxide. So calcium hydroxide is put from the hopper at the top, and same time what is done? Chlorine gas is pumped from the inlet here, isn't it? Chlorine gas will be pumped from the inlet. So chlorine gas will start to move up. Calcium hydroxide from the top will move down. That is, these rakes, they will keep on rotating and making it fall down, isn't it? So that calcium hydroxide will fall down. Now when it falls down, same time chlorine gas will be moving up. So when these two things, two chemicals, when they combine, when they come and mix here, see, you can see calcium hydroxide from the top, that is the slaked lime is there. Then you have got the chlorine gas, isn't it? Now these chlorine gas and calcium hydroxide, they combine, and what is formed? Bleaching powder is formed, isn't it? Bleaching powder is formed. That is calcium oxychloride, CaOCl2, isn't it? And this bleaching powder, it will put all the bleaching powder down into the barrel, and it will be collected at the bottom. Okay. And what happens? What is the byproduct of this process? Along with bleaching powder, what is water, isn't it? Now what will happen to water? Yes, water, that is, we'll be pumping hot air, and that water will turn to vapor, and along with the unused chlorine gas, it will move out. Okay, so that is how the process of preparation of bleaching powder using the Bachmann's process. Okay, yes, then next we need to study about the properties of bleaching powder. Okay, properties. What are the properties, basic properties of bleaching powder? Okay. So the first property, it is a white powder. In some cases you can also see yellowish in color, isn't it? So it is a white powder which gives the smell of chlorine. It has got a distinct smell of chlorine. Okay. Now actually bleaching powder can be used to store chlorine. As such, storing chlorine is very dangerous. We cannot store chlorine gas safely, isn't it? So in order to store chlorine gas, we can store it in the form of bleaching powder. Okay, so that is the case with white powder. So this bleaching powder, it is actually a white powder. You can also, some cases you can see a pale yellow in color. Okay, and it is having the strong smell of chlorine. Okay, then next is what? It is soluble in cold water. When you dissolve in water, you can see, have you any time experienced dissolving bleaching powder at home? Yes. So,
Yes, teacher.
will you get any residue there?
No.
Some cases, some white residue, some white, you will be getting some white residue, isn't it? That residue is that of lime, isn't it? Whatever that is, you know, already know we prepare what? Using slaked lime, isn't it? So whatever calcium oxide lime is left, that is what is left at the bottom. If you dissolve this bleaching powder in water. So mostly it is soluble with cold water, okay? So bleaching powder, it is soluble with cold water. Then how is its reaction with acid? How do this bleaching powder reacts with acid? Bleaching powder when mixed with acid, you can see the salt calcium sulfate, isn't it? That is CaOCl2 when mixed with sulfuric acid, that is H2SO4. That time reacts to form a salt called calcium sulfate, CaSO4, isn't it? And along with that, chlorine gas is produced and water is the product. So these are the properties, that is bleaching powder, it is white powder, then it is soluble in water, then it reacts with dilute acids to produce chlorine gas, and we can store this chlorine gas as bleaching powder, isn't it? Because chlorine itself, it is difficult to store, that is why it is having a very distinct smell of chlorine. Have you smelled bleaching powder?
Yes.
Yes,
Yes,
a strong smell of chlorine you will get, isn't it? Immediately it will release the chlorine gas and the lime will be left behind, isn't it? So that is why, because chlorine will not, it's very reactive, it will just leave off, okay? So that is the properties, that it is a white powder, then it is soluble in water, then it reacts with acids to produce a salt calcium sulfate and releases the gas chlorine. Along with that, water is the product, okay? So that is about the properties. Now, so we discussed about preparation, then the properties. Now what next you want to see? Yes, very good. Uses of
Uses.
bleaching powder, isn't it? So what are the uses of bleaching powder? So it is mainly used in cotton industries, isn't it? In textile industries, you can make use of this bleaching powder. Okay, bleaching powder, that is in order to bleach the textiles, in order to decolorize it, remove the color, isn't it? And get a cleaner clothes, we can use this bleaching powder in textile industry. Then we can also use it in paper industry. In paper industries we can use, isn't it? Paper, wood pulp and all, isn't it? Lot of other dirt materials and all will be there in the wood pulp. So in order to make it clean, in order to make it white, we will be adding bleaching powder. So bleaching powder will be added in the paper industries to make it clean, isn't it? Then it is also used in laundries, isn't it? After washing the clothes, if you want to make your clothes much more cleaner, isn't it? That time also we use this bleaching powder. So the bleaching powder, it is used in textile industries, it is used in paper industries, then it is also used in laundries. Okay, so that is the main use of bleaching powder. The term itself, you should understand, bleaching. Bleaching means what? Decolorizing, isn't it? If you want to decolorizing, if you want to make the color little dim, or if for cleaning purpose also it is used. Okay, so that is the one major use of bleaching powder. We use it in textile industries, we use in paper industries, we also use in laundries. Now what is the next use of bleaching powder? Yes, we can use it for disinfecting drinking water, isn't it? So that is another use of bleaching powder. What is the term disinfecting mean? To kill, yes, to kill the
cleaning
germs,
water
isn't
from
it? Yes, to kill the germs or microorganisms present, isn't it? So that function we call disinfection, isn't it? So this bleaching powder can be used to clean the water. That is, if you want to make the drinking water consumable, you can add bleaching powder. So what it will do? It will kill all the germs and microorganisms present in the water, isn't it? So that process we also call sterilization, that is killing of these germs and microorganisms, we can also call disinfecting water. So in water tanks and all, have you seen, that is those who are staying in municipal areas and all, you can see that the water which you are getting from the municipal pipe, isn't it? It has got a strong smell of what?
Yeah.
Chlorine.
Chlorine,
Chlorine.
isn't it? Strong smell of
Chlorine.
chlorine will be there, isn't it? Because they will be adding bleaching powder in the water tanks in order to disinfect it, sterilize it, isn't it? Or make it free of germs and microorganisms, isn't it? And such type of water you should not use for washing your hair and all, isn't it? You should keep those water for some time. So that time what will happen? Yes, all the chlorine and all gas will, what will it do?
Evaporate.
Escape out,
Evaporate.
isn't it? Chlorine gas will escape out. So after that only you should use the water. Otherwise it will kill the germs of everything in your hair also, isn't it? So it will be very strong for your hair, isn't it? So always try to use that way, that water. Okay. Then what is the next use of bleaching powder? You know, it is also used as an oxidizing agent. It is used as an oxidizing agent in the chemical industries. In the chemical industries, you can use this bleaching powder as an oxidizing agent. You have learned about oxidizing agent in the first chapter. What are oxidizing agent? Yes, Vishnu San. One, Vishnu Sanal is there? Vishnu Sanal?
Hello, teacher.
What are oxidizing agents?
Um, Oxidizing agent in
Huh? Forgot? When you're learning
uh,
the second chapter, you forgot the first one?
teacher.
Yeah.
Oxygen.
Which provides oxygen, isn't it? The
Oxygen.
substances which provide
Which provide
oxygen or helps to remove the
hydrogen.
hydrogen, isn't it?
Hydrogen.
Yes. So such substances we call oxidizing agent. On oxidizing agent are the substances which gets dashed during a reaction. Reduce, yes, substances which gets reduced during a reaction, isn't it? So this bleaching powder, it is also used as a oxidizing agent in the industry. Then what else it is used for? It is also used for making wool unshrinkable, isn't it? In the wool industries and all, to make it unshrinkable. For that reason also, for that purpose also, we use bleaching powder. So these are the main uses of bleaching powder. It is used in textile industries, it is used in paper industries, it is used in laundries, it is used for disinfecting water, it is used as an oxidizing agent, it is also used to make wool unshrinkable. So this is what we had for you today, and I hope you had enjoyed the class and all the little more experiential way of learning you could have, and whatever all the today we discussed about the properties of acids and bases with litmus. We discussed with the how it reacts with metals, then we discussed how it reacts with sodium carbonate. All the reactions also we were able to show you, and I hope you understood that. Then we discussed when we mix acid and base, what do we get, and how can we make new chemicals from these salts. And the one chemical substance which we prepared for today was what? Bleaching
Ble-
powder. Yes,
bleaching
bleaching
powder.
powder. And it is prepared in which plant? Backman's plant. It is prepared in Backman's plant, isn't it? So what are the chemicals used for bleaching, preparing bleaching powder? Dry slate lime and chlorine gas, isn't it? Dry slate lime and chlorine gas we mix, we will get
Chlorine
calcium
gas.
oxychloride, isn't it? Calcium
Oxychloride.
oxychloride or CaOCl2. So yes, and we also studied about the properties of this bleaching powder. We also discussed about the uses of bleaching powder, and I hope yes it was a great session for you, isn't it?
Yes.
Yes. Okay. So
Yes,
yes,
teacher.
yes. So thank you all for enjoying the
Thank you,
session,
teacher.
and today's class is over. If you have
Thank you, teacher.
Thank you,
yes
teacher.
any doubts, you can stay
Thank you,
back.
teacher.
Okay. Yes. Thank you all. Thank you.
Thank you, teacher.
Thank you.
Thank you, teacher.
Thank you, teacher.
Thank you. Thank you,
Thank you,
Makla.
teacher.
Thank you. Thank you. Bye. Bye. Thank you. Yes.
It
Thank
was
you all.
wonderful, Ras. Thank you, teacher.
Thank you, Mulesravani. Yes.
Thank you.
Thank you. Thank you.
It was super.
Thank you, teacher.
Super. Very good.
Thank you,
Fine.
teacher.
Thank you, Makla. Thank you.
Nice experience.
Thank you, teacher.
Thank you, thank you.
Thank you, teacher.
Thank
Nice
you.
class, teacher.
Thank you, Mone.
Nice
Thank you.
class, teacher.
Thank you, Mone. Thank you.
Super teacher.
It was
Thank
awesome.
you.
Wonderful. Thank you. Thank you. Yes.
Hello, teacher.
Yes, anybody have doubt? Yes, who is it?
Teacher, can you please repeat preparation of calcium? Sorry, teacher. Washing. Oh, teacher.
Bleaching powder, bleaching powder, Shreya, bleaching powder.
Yes, teacher. Yes,
That is, we prepare in Backman's plant, isn't it? So in the Backman's plant, at the bottom, we have got two inlet pipes. Through one pipe, we will be pumping chlorine gas, and through the other pipe, we will be pumping hot air. Okay. So, and from the top hopper, we will be putting calcium hydroxide, dry slaked lime. From the hopper, we put the dry slaked lime. So, this dry slaked lime will fall down. At the same time, which gas will move up? Chlorine gas will move up, isn't it? So this calcium hydroxide and chlorine will react, isn't it? And that time which chemical substance is formed? Calcium oxychloride or CaOCl2 is formed. Okay, along with this one more product is formed, that is water. So that water is the byproduct in the preparation of bleaching powder. Okay, now this water, if it remains there, it will come along, it will mix with the bleaching powder, isn't it? For that reason, in order to remove that, what is done? Hot air is pumped from the inlet. The bottom there is a hot air pump, isn't it? So that air will make this water into vapor. So this vapor along with the unused chlorine that will move up, and through the outlet pipe it will be put outside as the waste material. So that is, and this bleaching powder, it will, this barrels will, that is whatever shells are there, they will make it fall into the barrel at the bottom. So that is how bleaching powder is collected. So is it clear?
Yes, teacher. Thank you, teacher.
Thank you, Mola. Thank you. Anybody else?
Teacher, super class,
Thank you,
teacher.
teacher.
Thank you, Makle. Yes. Anybody else?
Fantastic experience. Thank you, teacher.
Thank you, Mona. Thank you. Anybody else? Any doubts? If you don't have doubt, then you can exit.
Okay, teacher. Bye.
Okay, bye. Thank you, Mone Makle. Now you can
Thank you, teacher.
Yeah, thank you. If you don't have any doubts, you can clear the session. Yes, exit. Anybody else? Any doubts? Nothing.
Thank you, teacher.
Thank you all of you. Thank you very much.